Just waiting for the slides to show up. Hope everybody's having a good week here in Singapore. Oh, here we go. Do I have a clicker or something? Oh, okay. Sure. Oh, okay. Yeah, so I guess I will just tell them when to flip the page. Okay, so just a quick introduction. My name is Jialin. I'm a co-founder of Hetu Protocol and Affiliate Labs. So today I'm very excited to tell you more about our latest development in building what we call deep intelligence money. Unfortunately, some of this, well, this is the PowerPoint over here. It's actually essentially the PDF because it's blocking. There's some technical issues, but so bear with me. Okay, yeah, so as I said, we're excited to tell you more about our latest developments in deep intelligence management. Okay, so I don't think I need to spend much time convincing you that AI has been great, so amazing. And I think everybody have first-hand experience using these AI models these days. So me personally, I usually is a sort of a slow adopter to technology. So when ChatGPT first came out a few years ago, I was a bit hesitant to try it. But yeah, but I started using it. It was quite amazing, and especially more recently, I started using it more and more. So I do research in computer science. I also teach computer science. So a lot of my workflow, including things like writing code, and I recently started using those coding agents. I was quite surprised at how good they are in terms of writing reasonable quality code. Of course, they make a lot of mistakes, but this is already exceeding my expectation, and I would assume they're going to be better and better moving forward. So anyway, so AI and AI agents, they are basically everywhere these days. Not just chatbots, even coding agents, but you see them in all kinds of areas like content creation. You use them to create pictures, videos. The latest Sora 2 is quite good, and of course boosts productivity. Right, so I already use these AI tools to help me with all these boring forms I have to fill in. So it does increase a lot of productivity. And things like process automation. A lot of companies are replacing human with AI to automate a lot of these tasks. Maybe that's good, maybe that's bad. And also in like scientific areas, right? So like these AI models pushing the boundary of science, finding new materials, molecular structures, aerospace engineering, even proving mathematical theorems. So not long from now, so this is no longer a science fiction, but we will have AI and AI agents all over the place in our society, in our economy. But there's one question: is with this more AI infused society and economy, what should be the real currency? Okay, we do have a lot of existing currencies, things like US dollars, USDT stablecoins, cryptocurrencies, Bitcoin, Ethereum. Okay, so they're okay, but we find that they are not really capturing the value of AI. Right? So if we actually want to move into this AI economy, then we need something that is more native, that actually capture their values. So why are we doing this now? Okay, so I think from my own perspective, there are two reasons. The first, as I already said, the AI is just becoming more and more powerful, and then they are going to be part of our lives. They already are part of our lives, but it's just moving forward. There will be even more. So that's point number one. So I think everybody should probably agree. I mean, even like all the big corporations think that and are already incorporating AI in their daily workflows. So we need to talk about this now. The second point, I think these AI models are very, very good at the moment, but you can already see that their improvement have been slowing down. Right? So the scaling of them have been less than what people are expecting. So one of the key reasons is that we have already used up most of the publicly available data to train these powerful AI models. Right? So if we cannot find much more valuable or good quality data, it's a bit harder to get much better training out of it. So moving forward, but we have all this sea of high expertise in certain domain-specific areas, all this good quality data, but just hidden among scientists, experts, and just between you and me, right? So if we want to build even further better models, we need to be able to incentivize people, and especially domain experts, to be able to contribute to this process, creating better quality models. But existing token and earning models, they don't really properly reward all these AI participants that well, right? So that's why we think it is important for us to define a new type of AI native currency with proper and verifiable value attribution, so that more people and more experts can help us build better models. Okay. So with that, Hetu is attempting one of these solutions to build a deep intelligence money, what we call Flux. So Flux is not a conventional token or conventional money. So this is what we really want to build, is AI native currency for the AI economy. Okay. So the real goal is that in the future, where AI agents are common in the daily workflows, including AI agent to human interaction, or even AI agent to AI agent interactions. Right? So these type of currencies should directly use for things like payments, microtransactions, and things like service exchanges. Okay. What is more, so not just because you can use them for all the kind of AI interactions, but also it should be able to capture the true value of artificial intelligence. And more importantly, we are going to we have already designed a new mining model that rewards meaningful contributions in the both the AI creation process, but also the AI interaction process. Okay, so I am myself a technical guy, so I would like to at least talk about some of the main technical pillars behind the Hetu Flux currency. I'm sure people here don't want to listen to me spending 20 minutes talking about math and computer science theories. So I'll try to be as high level as possible. From a high level, so Hetu Flux is built upon three important technologies. One is the Hetu causality graph. Second is a new consensus protocol and the mining model called proof of causal work. And lastly, a proof of semantic alignment to handle more alignment issues, things like ethical concerns. Okay, I will start with the causality graph of Hetu. Okay. So as I said, we want to capture true value in the AI economy. But what is the true value in AI? So I think that's a question that everybody have their own different opinions. So at least our perspective in here is similar to when we first invented money. Right? So why do we invent money? Because it is easier for us to exchange goods. Okay? So before money, people just exchange their goods for other goods they need. Okay, so essentially money is a way for you to find real utilities in your life, right? Being you use money to purchase this food or buy tools that you can use. Okay, so I think AI is the same, right? So we need to find true utility in this AI economy, and then we use the money for that. Okay, but so how do we find these true utilities? Okay, so I think this really comes from these meaningful contributions to AI. Okay, so what are these contributions to AI? You can imagine, for example, right? So you are using a big AI model, and then that actually brings some real impact to like humans. For example, you have ChatGPT help you to do some work. Okay, so that's I think true outcomes. Okay, and how do we find who actually contributed to these true outcomes? So I think so to do that, we find that we are going to use what we call the causality information. So we are going to find all the causal relationship or all the events which causally has causal contributions to this final outcome. Okay. So what are these causal information or causal relationship? Okay, just give you an example. Right, so I'm currently giving you this talk. I'd like to think that I do have some positive impact to the audience. Right, so and then we need to find out, okay, who actually contributed to me giving this talk. So who are the events that have causal contributions? Then we can go backtrack. Feels like, okay, so at least there's me actually making these slides, of course, that have direct causal relationship. And then there's me discussing with my teams. My teams actually contributed their ideas. And then that also have direct causal relationship to this me giving this talk. But you can also go further back, right? Things like some of these theories I have to build this protocol come from, for example, my college lecturers teaching me how to do distributed systems. Okay, so they also have like causal relationship to behaviors. And then eventually you can actually build some sort of this graph where these vertices are these actions who have impact, and then these edges are pointing with actual causal relationship. And if you think that I cannot have, my current actions cannot impact my past actions, then really this graph there's no cycles in this graph. So eventually we built a directed acyclic graph called the DAG, representing all the causal information that leads to all kinds of outcomes. Okay, so we're talking about AI. So one example of this causal model or causal graph, causality graph of AI system could be, so for example, you have, let's just say you have a good agent, coding agent, that actually serve people writing code. And then we can keep track of all the possible events that contribute to that final coding agent. Maybe there's like some, of course, some big models, and then there are some fine-tuning based on some coding specific tasks. And then going back, those were generated from some big compute networks, right, with big GPU servers. And then you can keep going back, and you have all these users. Maybe they write some coding questions, some Stack Overflow, so all these data are collected and then help to train, right? So then you can just build this graph with these edges pointing towards this causal relationship. So that's a very abstract way of thinking about AI impact and all the actions that actually influence them. But it is impossible for us to build something like a central system that just keep track of all this gigantic causality graph. Right? So what we really need, so for example, you cannot use a central server to do this, both for scalability reasons, because it's hard to maintain such a big graph, and also for security reasons. You don't want to trust that single entity to maintain this big causality graph. So what we do is we design a distributed protocol or decentralized protocol to do this in a fully distributed, scalable way. Okay, so but we are not the first one to think about this problem. Actually, back in 1978, the famous computer scientist Leslie Lamport already been thinking a lot about this problem and published a very influential paper on how do you determine the causal relationship in a distributed system. And that protocol is called logical clocks. Okay, so unfortunately, I don't think I have the time to explain the details of that protocol, but it's a very elegant protocol, right? So essentially what you do is you just attach some timestamp in all the messages you send throughout your distributed protocol, right? And then once you receive those messages, you update the clock and then further propagate the clocks to downstream events. Okay? And by doing that, we don't need any centralized server to do this, and then we can build these what we call logical clocks that can concisely represent the causal relationship between any two events in a fully distributed system. Of course, back in 1978, when Leslie Lamport think about this problem, he wasn't really thinking about like what happens if you apply it to a blockchain system, a permissionless system, because you need to solve the security problem, right? Because some malicious actors may be able to come and change the clock values and distort the causal relationships. So what we did is to build upon Leslie's work and apply things like zero-knowledge proofs and TEE to build a fully trustless and a secure logical clock protocol, and we call it verifiable logical clock. So I just use VLC to represent this protocol later in the talk. And by using this protocol, we are able to build what we call decentralized knowledge graph, essentially the causality graph we talked earlier, but with some security guarantees. And because we don't rely on any centralized entity, and this is not a consensus protocol, right? So we avoid a lot of the consensus bottleneck, so we're able to do it very scalably, so we can achieve 1 million plus operations per second. Okay, so far I covered the basics of how do we build this causality graph using a distributed protocol. But you may be wondering, okay, so far you still haven't talked about the currency. Right? So here it is. Okay, so leveraging this causality graph, we build a new form of consensus protocol and mining mechanism so that you can actually earn this flux currency. Okay, so this new type of currency, you earn it by contributing causal work. So this is similar to, okay, so everybody probably are very familiar with proof of work, right? So you spend your GPU or your ASIC power to mine some Bitcoins, for example. So here is similar, right? So you also do some work, but instead of doing calculating hashes, right, which is meaningless, we encourage you to actually do useful work. So, but what is useful work in this particular network? So the useful work is when you actually extend the causal relationship on a DKG. So that means you are extending the current graph with some new causal information. Okay, so for example, right? So for example, you can see, oh, okay, there is a DeepSeek model, and I want to extend that by contributing my own fine-tuning on top of it. Then you create a causal relationship on top of that DeepSeek model vertex. Okay, but that itself doesn't really create any value, right? Because you are just extending the current graph. So we will have validators that come and help and check that your contribution is meaningful, right? So we will discuss all the validators do that in the next slide. But if there are validators, enough validators to think, okay, so your contribution is meaningful, then they will further extend based on your current causal relationship. Okay, so eventually more and more people will come and see, okay, so whatever you did, maybe you create a new model, is actually useful. Then they'll keep further extending on your current vertices. And then finally, we can calculate the value of your causal work based on both the depth and breadth of the DKG that extend upon your event. Okay? And the nice thing is that we don't need to invent a completely new security protocol to guarantee that your work is correct, because we can rely on the verifiable logical clock, what we did what I showed last slide, as a verifiable proof of your causal work. So whenever you can present your VLC with your signature, and then we can see, okay, so there are a big chunk of DKG that extend upon you, then we can give you the value of flux. Okay, so finally, there are some mathematical formulas how to be based on a correct DKG, and then give you the actual flux tokens. But I'm not going to cover the math. If you're interested, we also have a light paper to explain how we do this calculation. Okay, so I think, yeah, this is slide. Okay, so I think there's probably another slide in between. Here. Not sure why this is come different time. Okay. So one thing about this DKG is that unlike a blockchain, so blockchain there is a notion of what is the the correct blockchain, right? So usually that means the longest chain. So in our case, we do not define a true objective truth in this new consensus protocol. Right? So the reason we say that this is a causality graph, the graph just keeps causal relationship. It doesn't really tell you what is the correct relationship, or what is the correct version of the graph. Right? So you can, for example, you can think, okay, so I feel like DeepSeek is better, so I'm going to extend upon the DeepSeek with some new causal information. Or some other people may think, okay, I like the coin model a bit more, right? So I work upon that model, right? So, but we don't say which is correct and which is wrong. Okay, so this is all based on the subjective notion. Unfortunately, this is also covered. The subject notion of each participant. Okay, so you can have your own subject notion of what is better, what is good, what is wrong. Okay, our protocol only ensures that there can be no forging or tampering with causal relationship. But which causal relationship is good is completely decided by the network participants. Okay, but eventually there will be enough participants who agree upon some certain nice events. Then we say that we achieve intersubjective consensus, right, which is collective agreement by peers with some common values. But so there are also problems with AI, things like ethical reasons, right? So so people have different principles. Okay. Oh, okay. So I think I'm running out of time, so I'll just quickly skip this slide. So basically, we do have a protocol that so the validators can, based on some equations, decide what is the semantic alignment of these different actions, so that we can only award those with the aligned with the current principles, community norms. Okay, so just quickly running through some of the remaining slides. So one interesting thing about Flux is that they are not transferable, unlike your typical tokens, right? So it really represents more like a reputation, like your capability and your track record, and you cannot just simply give your tokens, your Flux tokens to someone else. Okay, but at a certain time, you actually want to use this for your actual utilities. And to do that, we do have a way for you to burn these Flux tokens to withdraw stablecoin via a liquidity pool. And then, so this is a one-way bridge, you cannot convert it back, right? And the exchange rate is determined by the supply-demand dynamics. But eventually, if you want, you can exchange this Flux for stablecoin to be used for your other economic activities. Okay, because of running out of time, I'm not going to spend much time on this slide. Essentially, we're also, to back this up, right, so all these highly frequent AI interactions in the AI economy, so we also build a highly scalable a chain using our research on DAG-based BFT protocols and our sequencing layer. Okay, but if you're interested, you can check out our paper. So that is the whole architecture of Hetu Flux, right, putting it together. So we have three important technical pillars. And using this, we're able to generate these Flux tokens, and which you can burn to some stable coins, we call it USD AI. And then it's all on top of our hyper-scalable DAG chain. Okay. So with that, I would like to conclude my talk. And then if you are interested in any of our technical information, feel free to check our website, our Twitter, and our GitHub pages. And I'll be also happy to chat with you after the talk. Thank you very much.